Hi, so this video is not really a lecture, it's a supplemental material for vectors and scalars, a deeper look into vectors, so that when you first meet vectors, sometimes it can be difficult to grasp the difference between a vector and a normal scalar. Okay, so let's hope this video makes sense. So in physics, we'll encounter two different quantities, vectors and scalars. How are they different? Scalars are just like ordinary numbers, or ordinary positive numbers. They don't worry about any direction accompanied with them. Okay, so for example, speed is a scalar. So how do you measure speed? Speed is equal, say, 5 meters per second. So you have a number with a unit. That's enough to say what your speed is. But when you move on to vectors, in addition to the numbers, your direction becomes important as well. So for example, velocity is the vector quantity corresponding to a speed. So how is velocity different from speed? So you just can't say, if you're asked to find out velocity, that your velocity is 5 meters per second, because that information is incomplete, because you're only giving the magnitude of velocity, which is the speed. But to have a complete definition of the velocity of a moving object, you have to say someone or some object is moving at 5 meters per second in a specified direction. When you mention that specified direction, for example, due east, due north, due west, due south, or however you choose to denote that direction, then we'll say that that's a vector. So let's look at an example. So let's say you wake up one day and want to go to a shop. So you start your journey from home at, say, 10 a.m. and then travel to the shop that's nearby, which is around 30 meters from your home. Okay, so now you walk from home to the shop, you get your stuff, so you walk home 30 meters, right? So one way you go home to shop, and then you get your stuff, come back again. So from shop to home, you cover the exact same distance twice, right? Once you go from house to shop, then you go from shop to house, covering the same distance. So if I ask you what the distance is, the distance for this journey should be equal to 30 plus 30, which is 60 meters. Okay, so notice that scalar distance is a positive number. So the total distance should be the summation of two positive numbers. One, the distance from home to shop, and two, the distance from shop to home, giving you the total distance to be 60 meters. Now, if I asked you what the total displacement would be, then you would be surprised to know that it will be 0 meters. Why? Because vectors, directions are important, and directions can be denoted in a multiple ways. So let's say we have a coordinate system that goes from your house, which is here, which is the origin of your motion, to the shop, which is your destination. Okay, and in that coordinate system, you go from this way 30 meters to the shop, and in that coordinate system, anything going this way is positive, and so anything coming that way from right to left is negative. Okay, so you cover a distance of 30 meters going from left to right, then you get your stuff and come back the exact same distance, but now from right to left. So the total displacement understandably is 30 meters in the positive direction plus 30 meters in the negative direction, which is equal to 0 meters. Okay, hopefully that makes a lot more sense. Let's look at vectors a lot closer. So we have seen that we can add and subtract scalars, we can add and subtract vectors. But adding and subtraction of vectors is significantly different than adding and subtraction of scalars. How so? Let's check out. So, for example, we have a vector denoted by an arrow labeled A equals 2, meaning this vector is called A and its size is 2, or its magnitude is 2. And then also we have a vector B whose size is 4 meters. Let's not call them meters, let's go for a general vector. They can be anything. So let's say we want to add them. So we have a plus sign here. So when you add them vectors, both are pointing from left to right, and both we can say, let's denote them on a coordinate axis and denote this direction to be the positive direction. So when we add, we get a combined vector which is bigger than either one of them, because these two vectors add up to give you this resultant vector, which is 6. Okay. All right. Now let's look at a more detailed example. Say vectors can also be vertical. So you can have a vector going up like that, and let's call this vector C, and let's say its size is 3, magnitude, and then you have a vector which is pointing downwards, and let's call this vector D, which is whose magnitude is say 7. Okay, and then these two vectors are on a coordinate system whose positive axis is anything that is pointing upwards. So when we add the two, notice what happens. We have a positive vector C going up, which is positive, that is added to a vector D which is going down, so that's a negative vector, minus 7, which gives you minus 4. So that by adding these two vectors you get a resultant vector which is pointing in the negative direction, so which is pointing downwards, and its length is somewhere in between 7 and 3, which is 4. Okay. Also, in addition to being horizontal or vertical, vectors can also be pointed at an angle. So vectors may look like this. Let's now call this X. Okay. No, let's not call them X. Let's not call it X. This, let's label it as W. Okay, so this is the W vector. It's pointed weirdly, and say we know that this is the x-axis or horizontal axis. It makes an angle theta with the horizontal axis. Okay, so vectors can also be pointed this way. So let's say we have another vector like so. this is x, this is y, this is the y direction, this is the x direction. So let's say this vector, let's use a different color now. Let's say this new vector is pointed like this, and let's call this P, and we want to add these two vectors. Okay, let's say this has magnitude of 5 and this has magnitude of 3. Okay, and we want to add the vectors. Oh, and this vector makes an angle, let's call it phi, with the vertical or y-axis. Now, if these were two scalars, you would just go, the total value of the scalar is 8 by adding 3 to 5. Okay, but these are not scalars, these are vectors. So because they're vectors and they're pointed at an angle to different axes, what we have to do for vectors differently is to know that vectors have all vectors have two different parts to it. So any vector like W will have x part and a y part. Any vector P will also have an x part and a y part. Similarly, any horizontal vector, let's say this, let's call it A. A has an x part, which is this, and a y part, but that y part is 0. Okay, so any vector can have two parts. We call these parts components of vectors. So from now on, we'll denote these as x components and y components of vectors. So when you add two vectors, you have to add x component to x component and y component to y component. Let's see how that's like. So first of all, you have to find the components of the vectors. How would we do that? Right angle triangles. So that whenever we work with any sort of vector, right angle triangles is our way forward. So W, it's going up and like this. So its x component will be pointed along the positive x-axis, since it's over the positive x-axis. And if you think this is my positive y direction, and since the vector is going up, so vertically increasing, so the y component of W will also be pointing up. We will denote the y component to be Wy and the x component to be Wx. Let's see what we can do for P. P is going down from here, and this is on the same coordinate system as this vector. So this way is positive x and that way is positive y. Okay, so it's going down, vertically decreasing, horizontally decreasing as well. So the components would look like this. Would be my y component decreasing in a downward direction, and this would be my x component decreasing in a leftward direction, and we denote this as px, denote that as py. Okay, then we have our right angle triangles because these are right angles. Now what? Now, since we know this angle can be anything that will be given to you or you'll be asked to find it, doesn't matter. This angle can be anything, this angle can be anything. So we'll use this angle and the fact that this is a right angle triangle and use simple trig relations to get px and py. Okay, so let's say we want to find wy. So then this is a right angle triangle. wy is opposite to this angle, and we will always use this resultant or total vector. This is my total vector from which these two are the parts. So our resultant vector w is made up from its x component and its y component. So these two vectors combine to form the resultant vector. So the hypotenuse of the right angle triangle is my resultant vector. So I'll always use this to find components. So this is opposite, this is hypotenuse. So we have sine theta is equal opposite, which is wy, over hypotenuse, which is, will only take the magnitude of w. So that is 3. So wy is nothing but the magnitude of w, which is the resultant vector, the length of the hypotenuse, times sine theta. Okay. Similarly, we can find wx, because this is the adjacent of the right angle triangle. We'll have cosine theta equals adjacent, which is wx, over hypotenuse, which is the magnitude of the resultant vector. So wx is magnitude of w times cosine theta. Okay, so these are components of the vector w. All right, let's move on to finding what we have there. So we'll use similar right angle triangle, but see, now px is the opposite, py is the adjacent to that angle. Okay, so for px we'll have sine theta equals opposite px over hypotenuse, which is magnitude of p. So px is magnitude of p times sine theta. Similarly, for py, this is the adjacent, so you can use same as this and find py is equal to magnitude of p times cosine. Actually, forgive me, these are not thetas, in fact these are phi's. Okay, all right, so we have found components. Now how would you add the two vectors? You would add the two vectors by components. So you would find the total x component, total x, which would be the summation of px and wx. So px plus wx. Okay, and these, remember, these are vectors. So py is directed negative, so this is actually negative, and px is also directed negative, so this is also negative. All right, so px plus wx would give you the total x component, which is negative p sine phi plus wx is magnitude w cosine theta. Similar, total y would be py plus wy. Okay, you will just add wy to py. Now what happens is, since you have a total x and a total y, this will give you the total triangle after adding the two vectors w and p. The total triangle would be p x plus wx py plus wy, making a right angle triangle, and let's call this angle alpha to show that alpha is actually different from either theta or phi. So this alpha is the direction of the vector, because remember, whenever you say that the vector is at an angle, that automatically means you're giving a direction to that vector. So this alpha would be the direction for the new addition of the vectors. Okay, so we call the hypotenuse the resultant vector, which is the total p plus w added together, and this p plus w is actually broken down into px plus wx, py plus wy. Okay, and this is the direction of the newly formed vector. I hope that makes sense.